Hi, this is Unit 4, Lesson 3, Graphing Circles. So the definition of a circle is that it's the set of all points in a plane that are a fixed distance from a center. And the fixed distance between the center and the edge of the circle is called the radius. So on my diagram over here, this point is the center of the circle. And every single point on the edge of this circle, all the way around, is exactly the same distance away from the center, and that distance is called the radius of the circle. Two other parts of a circle that you should be familiar with from prior classes is the circumference. The circumference is the distance or the length of that whole edge of the circle. It's like the perimeter of the circle. Circumference formula is 2 pi times the radius. That's a handy formula to know for like the ACT and things, if you know that one. And then to calculate if we wanted the area of a circle or the space that it occupies, we would use the equation pi r squared. So you're probably familiar with those two. It's great if you know those two formulas. What our goal is in this lesson is we want to be able to graph circles on a coordinate plane. So we're going to think about what their equation looks like. And the equation of a circle is actually based on triangles. So if I have a whole bunch of these points on the edge of the circle, I could call that point xy. And if you kind of picture a right triangle here with the radius of 5, or the radius is the hypotenuse of the triangle, then you could think of the Pythagorean theorem. And for this particular little triangle here, we would have the leg squared plus the other leg squared is equal to the hypotenuse squared. And the circle you could think of is made of all these points on the edge, and for each point on the edge we could build a right triangle. And since the hypotenuse of the right triangle is always the same, it's always the radius, that equation will always be true for every point on the edge of the circle, that x squared plus y squared is equal to 5. So our circle equation is going to look exactly like that. It's going to look like x squared plus y squared is equal to the radius squared. Now usually we do actually square out the radius, so this circle's equation would be x squared plus y squared equals 25. So if I wanted to graph this circle, x squared plus y squared equals 16, this circle is centered at the origin, and the thing that appears right here, it's not the radius. We don't want to count out a radius of 16. This is the radius squared. So the radius would be 4. So to graph the circle, what you would do is start at that center point and count out 1, 2, 3, 4 in each of the 4 directions. 1, 2, 3, 4. And over here, 1, 2, 3, 4, and then down 1, 2, 3, 4. And just by finding those 4 points on the edge of the circle, we can get a pretty good diagram. Ooh. At least good enough for what we're doing. So try your best to make them as circular as you can. Don't do this because that's not trying. So don't do a little like squarish shape that's diagonal. Do try to show that your circles are rounded. So not all circles have to be centered at the origin. We can have them translated around to different center points. So this circle, for example, has a center at 2, 3. So we would still kind of think about triangles to come up with a way of writing the equation, but it's a little bit more complicated because the length here is no longer x. So if we think of our center as HK, these lengths become x minus h and y minus k for our two legs. So the general equation of a circle that's not necessarily centered at the origin looks like this. Again, it's based on the Pythagorean theorem and the side lengths of the triangle, but it gives us the equation for all of those points all around the edge. Okay, so x minus h squared plus y minus k squared is equal to r squared. So the center is at hk. Both of those are going to have a little sign change. The y one does as well this time because it is grouped in that squaring. We do have a sign change. And then just be really careful that the number here is not the radius. This is the radius squared, so our radius would just be r, which would be the square root of the number that's in the equation. So let's graph this one. Usually just after graphing a couple, you'll get the hang of it. So this equation, x minus 2 squared plus y plus 4 squared is equal to 9. That tells us that the center of the circle is at 2, negative 4. So make sure you do a sign change for both. And then because this is our r squared, we know that the radius must be 3. So I'll mark my center, 2, negative 4, and then from there I'm going to count out 1, 2, 3, up 1, 2, 3, back 1, 2, 3, and then down 1, 2, 3. And those 4 points give me my circle. Sorry, it's hard to draw the circles on my tablet, so mine aren't looking that hot today. Okay, so before we graph anymore, I want to practice just identifying the center and radius of the circle from the equation. So here's our first circle. So we would have a center at 2, negative 3. Make sure you do a sign change for both of those center point or center coordinates. And then the radius, remember this is r squared, so the radius here would be 7. For this one, if we're finding the center, we can see that it's at negative 4, but what's happening over here? So this is a case where our center y-coordinate is going to be a 0. There's not a number being added or subtracted from that y. So our center would be at negative 4, 0. And for our radius, remember that this number in the equation is r squared, so our radius here would be 10. Last one, fancy one. So our center is going to be at negative 1, 5, and that's a positive 5. And our radius here is a little tricky. R squared is 20. So we would need to take the square root to find the radius. So the radius in this case is 2 root 5. Now, I'm going to graph one in a second that doesn't have a whole number radius, but just know that they don't necessarily have to be a whole number. They could be something like 2 root 5 or some decimal amount. Okay, so now that we've practiced identifying the center and radius, we can go ahead and graph a couple more. So our equation is x minus 2 squared plus y squared is equal to 81. So our center would be at 2, 0. So I'm going to graph that right here. And then r squared is 81, so that means our radius is 9. So counting out 9 in each direction, 1, 2, 3, 4, 5, 6, 7, 8, 9, barely fits. And up, 1, 2, 3, 4, 5, 6, 7, 8, 9. Back 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I like the small circles better. That's hard to count all those out. Okay, and then here is my not very beautiful circle. Hopefully yours look a lot better than mine. Okay, so on this one, we're going to go ahead and graph the domain and range. So when you're writing the domain, you're going to think about it from the left side to the right side. So our farthest left value is negative 7. And our farthest right value, even though my circle is kind of ugly, is 11. I'm using brackets on both sides because those points at -7 and 11 are included on the circle, so we want to use brackets. For the range, you want to think about it from the bottom to the top. So the lowest value on this circle is -9, and it goes up to a high value of +9. So there is our circle and its domain and range. Another circle, so this one has a center at -4, +2. Don't forget to change both those signs. And then our radius squared is 10. So that means our radius is the square root of 10. Now, telling someone to count out the square root of 10 on a graph, that's terrible. We do need to know about what decimal that is. So I have the decimal equivalent down here at the bottom. So that's about 3.16 or 3.2. So just a little bit larger than 3. So when I count it out, I'm just going to kind of go a little bit past the 3. 1, 2, 3 up here, back 3, and down 3. A little bit past 3. So here's my circle. Now, if you ever had to write the domain and range of such a thing, I would use the root 10 to write the domain and range. And I think this is kind of interesting. So I'm not going to use the 3.6. I'm going to use the root 10. So when I'm thinking about the domain, it's from here to here. And this distance is that I subtracted the root 10, and this distance is that we added a root 10, and the number that's at the center there is -4. So my domain is, and this is kind of cool, is -4 minus root 10 all the way to -4 plus root 10. And the range is going to be kind of similar. We're going to add and subtract that root 10, but the center of the range is at a height of 2. So it's going to be 2 minus root 10, and then 2 plus root 10. So, I mean, that's not something I'm going to ask you on a test or anything. It's just kind of interesting and good to think about that they aren't always whole numbers, and sometimes we have to think a bit harder to come up with a domain or range. Okay, so here's just a couple more. Center would be at -1, -3. And the radius here is just 1, because 1 squared is 1. So this is just a little teeny tiny circle, easy to count out. And this next one, oh wait, it says to do the domain and range. So here our domain, left to right, would be -2 to 0, and our range, bottom to top, would be -4 to -2. All right, now we can do this one. Our center here is going to be at 0. We don't have a horizontal shift with the x there, and our y coordinate is going to be 1, so 0, 1. Our squared is 25, so that means our radius is 5. 1, 2, 3, 4, 5. Now I need to go 5 up, 5 back, and 5 down. Kind of missed that side. All right, so the domain left to right is going to be -5 to +5, and the range bottom to top, -4 to 6. Okay, so now that we have practiced graphing those, we're going to write their equations. So when you're writing the equation, remember that you have your center with the x and the y. Something to not forget is that both are squared, like the Pythagorean theorem, and then we also have the radius squared. So sometimes I think it helps to remember that your circle equation is based on the Pythagorean theorem to help you remember that all those squarings are happening. So this one would be x minus 1 squared plus y minus 2 squared is equal to 4 squared, but I would prefer you to go ahead and square the 4, so that was going to be a 16. Now on this one, be careful. It does not give me the radius, it gives me the diameter. So on a circle, the radius is the distance from the center to the edge. The diameter is the distance all the way across. So if the diameter is 16, that means the radius is 8. So if we write our equation, it's going to be x plus 3 squared plus y minus 4 squared. So I put in my center, negative 3 becomes positive x plus 3, and then 4 here becomes y minus 4 in the equation. And that's going to be equal to 8 squared, which is 64. Okay, so now we're going to do that same thing, but from a picture. So we maybe just have to pause and, think about where the center is shown to be. So this first center is at negative 2, positive 2, and the radius, if I count it out, is 1, 2, 3. So our equation would be x plus 2 squared plus y minus 2 squared is equal to, and then 3 squared is 9, so it's equal to 9. This next circle has a center at 1, 2, and the radius here is 1, 2, 3, 4. So our equation is going to be x minus 1 squared plus y minus 2 squared is equal to 4 squared, which is 16. All right, one for you to try. If you want to pause and try it, you can. I'll write out the center and such. So pause if you want to try it on your own. Negative 2, 6 is the center. The radius here is 1, 2, 3, 4, 5. So our equation is x plus 2 squared plus y minus 6 squared is equal to 25. Okay, last one. We're going to use a description of the circle to sketch its graph. So it says the circle is centered at the point negative 2, negative 2. So I'm actually going to draw it and then use my drawing to help me answer the question. So it's centered at negative 2, negative 2, and it has a diameter of 10. Well, if the diameter is 10, that means the radius is 5. So I'm going to count 5 in each direction. 1, 2, 3, 4, 5. Up 1, 2, 3, 4, 5. To the left 1, 2, 3, 4, 5. And then down 1, 2, 3, 4, 5. So here's what my circle looks like. So our equation is going to be x plus 2 squared plus y plus 2 squared, that's a lot of 2's, is equal to, and then r squared would be 25. So let your teacher know if you have any questions on graphing circles. The assignment is in your packet, and thanks a lot.